Hi everyone, and welcome to the Data Collection Timing Lecture video. When selecting a data collection strategy, it's important to consider the time dimension, meaning the timing of your data collection. There are two main time dimensions, cross-sectional and longitudinal. A cross-sectional design means that data is only collected from the research subjects at one point in time. You take a survey, hand it in, and you're done. On the image here, you can see that this cross-sectional design indicated as occurring only at T1, which stands for time 1. Longitudinal designs, on the other hand, take place at 2 or more times, meaning you collect data from the research study at subject at least 2 separate times, and many times more than 2. Longitudinal data is ideal if you're conducting explanatory research, because if you only collect information at one point in time, you're only going to be able to observe the cause and effect simultaneously. By spacing your data collection periods across multiple time points, you will then be able to observe the cause first, identify that the effect is not present yet, and then later determine that both the cause and effect are present, thus proving a cause and effect relationship. There are further subcategories of longitudinal designs: panel, cohort, and trend. The difference in these three studies is not when the data is collected, but rather who the data is collected from. A panel study means that you gather data from the exact same research subjects every time you collect data. So we start with our research plan. We're going to collect data at time 1 and time 2. At time 1, we gather 5 people. When we go to time 2, whenever that is, we gather the exact same 5 people again and collect more data from them. The time period between time 1 and time 2 does not matter. It could be a day, an hour, a week, a year, even a decade. The important thing about a panel study is that we need to keep the exact same people. Panel studies are our best option for explanatory research because they allow us to document the exact time that cause and effect both presented themselves in each individual research subject. If subject 1 was smoking at time 1 but was healthy, and then at time 2 was still smoking and now had cancer, we can document that smoking came first and cancer came second. However, because panel studies keep the exact same people each time, this can make the research study more difficult to complete. For instance, what if person 4 dies before we collect data at time 2? Now we're left with 5 time 1 observations, but only 4 time 2 observations. This dropping out is called attrition. Attrition rates in panel studies are the highest of all 3 longitudinal studies because we rely on the exact same people. Attrition can be caused by people dying, like in my example, or by people opting out of the data collection, or people that are not able to be found by the researchers. The longer the time between time 1 and time 2, the higher the attrition rate you'll have because of these issues. Attrition rate concerns are why researchers will often utilize a cohort approach to longitudinal studies. In cohort studies, the researchers gather a group of people with similar characteristics each time, but they don't have to be the exact same people. For example, birth cohorts are a very common research approach in social science research. At time 1, the researcher will collect data from 5 people born in a specific year, let's say 1980. At time 2, the researcher will find 5 more people born in 1980. Because the researcher does not have the exact same 5 that they interviewed originally, the attrition problem is less. But now the cause and effect order is more suspect. Just because subject 5 was a healthy smoker at time 1 and subject 5 was a smoker with cancer at time 2 doesn't mean the same as a panel study, because now subject 5 is a different person. So maybe the subject at time 1 got cancer first and then started smoking. We have no idea. So cohort studies are good for attrition rates, but more problematic in terms of determining cause and effect relationships. The final type of longitudinal design is a little different. This type of design, called a trend study, doesn't look at individual people whatsoever. Trend studies look at populations over time. Because of this definitional difference, trend studies usually study at least 3 or more time periods and commonly include longer time frames than either panel or cohort studies. Because trend studies are looking at the population as a whole, the data collected at each time period will be some sort of rate or percentage with the goal of showing change over time. For example, here are hypothetical rates of gun ownership that are collected at 7 points in time. At time 1, using this totally made up data, 10.5 out of 100,000 people were gun owners. Time 2, 15 people out of 100,000 were gun owners, and so on until time 7, when 7.8 people out of 100,000 were gun owners. Researchers interested in understanding how gun ownership rates change over time throughout history would graph the results of all 7 time points and compare those rates to determine how this variable is changing over time. Shown here is a graph from the Center for Disease Control that illustrates the rate of violent deaths caused by firearms. The data is broken up into 4 categories. The blue line represents Black persons, the green represents white people, the purple represents American Indian people, and the light yellow represents Asian and Pacific Islanders. The rate of gun violence fatalities in all 4 ethnic groups is graphed, starting with the rates in 2001 and ending with rates in 2018. Like cohort studies, trend studies are not as good proving temporal order because you're not looking at individual people in the population. But trend data can be very useful in document overall trends to see how events are changing within a single country over time. The CDC actually has multiple online databases that allow you to analyze trend data in the United States for free. The URL in this slide links you to the CDC Wonder website, which will give you a list of all the different databases you can access. To get this graph, I used the link provided under cause of death, which took me to the fatal injury and violence database, where I could run all of these graphs and tables quickly and easily. This website may be of interest to some of you in future papers or for research projects. All right, well, that completes the data collection timing video lecture. Thanks for watching, everyone.